So we're going to continue looking at logarithmic equations. And again, we're going to do this by example. So the very first thing that I want to mention is that the argument of a log has to be positive, okay? If we go back to the very beginning of logarithms, if you remember, the log, the domain is x is greater than 0. So what we're taking the log of, the argument has to be positive. And if we think about it in terms of what a log is versus just the graph, there is no number that can be raised to any power to give a negative answer. In other words, if we raise a number to a power, we will never get something that's negative, no matter what the base is, as long as it's positive. No matter what our base is, and no matter what our power is, we're never going to get something negative. So this is important because it means that sometimes we're going to wind up getting a solution that is not valid. We call that solution extraneous, okay? It's an extraneous solution. So what it does is it's a solution that makes an equation work, but the equation is something that we're not taking into account what the original equation is. And you'll understand what I'm talking about in our first example. So our first example is log base 2 of 3x plus 4 is equal to log base 2 of 8x minus 2. And to solve this equation, we're actually going to use that very last property of logarithms that says if the bases are equal, the arguments are equal. Okay, it was this one. If log base b of x equals log base b of y, then x equals y. Okay, it was that property of logs. So if we say that, then what we're saying is that 3x plus 4 is equal to 8x minus 2. This is similar to in the previous video where we talked about if the bases of an exponential are equal, then the exponents are equal. Same thing is true here. If the bases of the logarithm are equal, the arguments are equal. And this is what I was talking about in terms of equations that we create that are not the original equation. So we're going to find a solution for 3x plus 4 equals 8x minus 2. And it will work for this original equation, but because we're not taking into account the fact that we're taking a log when we solve this linear equation, we might get solutions that won't work for our original equation. So if we go through and we solve this, We can subtract 3x from both sides and add 2 to both sides. Okay, that's going to give us 6 is equal to 5x. And then we can divide both sides by 5. So x equals 6 over 5. Okay, but we're not done. We have to check for extraneous solutions, okay? And what that means is we have to plug it back into the arguments. And show that you get a positive number. So that's what we're going to do here. 3 times 6 over 5 plus 4. We don't even have to solve. All we have to know is that it's greater than 0, which it is. And then 8 times 6 over 5 plus 2 is also greater than 0. So it's not extraneous. Okay, it's not an extraneous solution. So I know that this is greater than 0 because everything here is positive and we're just multiplying and adding. Okay, so we can actually box this as our final answer. Now, when you do these problems, you can't just box it and expect me to know that you plugged it in. You have to show me that it was plugged in. So you can either do this, at the very least, you have to say not extraneous, okay? But you should be showing that you've plugged it in and every single argument is greater than 0. As soon as you find an argument that's negative or 0, you can stop and you can say it's extraneous. Okay, let's do some more examples. And once you feel like you understand how to do it, or if you want to try on your own, again, pause the video, try it, then restart the video to see if you did it correctly. So we have log of x plus 6 is equal to 2 log of 7. Okay. So in order to set these equal to each other, in order to set the arguments equal, so we have the same base, so we can set the arguments equal to each other, but there's a coefficient here. And if you look at our original property, the original property does not have any coefficients. So we need to get rid of the coefficient first. And how do we get rid of a coefficient? We bring it back into an exponent. So we're going to move this here. So our first step is going to be to get rid of coefficients. And then we can say if the bases are equal, the arguments are equal. So it's going to be log of x plus 6 is equal to log of 7 squared. And now we can say x plus 6 equals 7 squared. 7 squared is 49. Okay, and you can, don't make yourself crazy. You can go straight from here to here. That would be okay. You can go straight from here to here. That would be okay with me as well. Okay, so you don't need to show the 7 squared step separately, but you need to show at least one of these steps so that it's not unclear what you did with this coefficient. Okay, and then if we just solve this, we can subtract 6 on both sides. So your last step is always going to be check for extraneous solutions. So we get that x is equal to 43. And 43 plus 6 is greater than 0. So this is not extraneous. We can box it. Okay. Okay, let's try one that's a little bit different. Because these are pretty straightforward, right? Get rid of your coefficients. You can set the arguments equal to each other. And almost always you're going to have some sort of linear equation. Okay. The next one. And we're going to be doing a lot of these. We have log base 2 of 3 plus log base 2 of x is equal to log base 2 of 5 plus log base 2 of x minus 2. And I will note that you must have the same base, otherwise you cannot solve these equations. Okay, so your bases will be the same. They will never be different in this class. Okay, so what do we do first? Well, this is actually, we can't do anything with this, but because they have the same base, what we can do is we can make it so that there's one log on each side. And we can do that by condensing, right? We see 2 logs over here that are being added. We can condense it by multiplying. So it becomes log base 2 of 3x on this side. And then log, I'm sorry, I'm going to rewrite this so that you can tell the difference between the solution and the question. So we have log base 2 of 3x is equal to log base 2. And here we just multiply again. So 5 times x minus 2. So whenever you see more than one log on a side, you're going to condense. This is going to be true for every example that we do. Okay, and in this case, we used the product property. And then you can do if the bases are equal, the arguments are equal. So from here, our bases are equal. That means our arguments are equal. So we have 3x is equal to 5 times x minus 2. And if we solve this, we're going to distribute the 5. So 3x is equal to 5x minus 10. And then we can just subtract 5x from both sides. This is just solving a regular linear equation. And we get negative 2x equals negative 10. Divide both sides by negative 2. And we get that x is equal to 5. And again, you're just going to plug in to every argument. So the first argument here is just a 3. You can't plug it into 3. So you're not going to do that. And same thing with the first argument on the right side. So you're just going to plug it into any argument that has x. 5 is greater than 0. 5 minus 2 is greater than 0. This is not an extraneous solution. We can box it. So you're solving for x. And then your check for extraneous solutions. Okay, let's take another example. So we have log base 2 of x plus log base 2 of x minus 2. I realized a lot of these are using base 2. That's purely coincidental. Is equal to 3. So remember what we said. If you see more than one log on a side, then condense. So we're going to condense here. So we get log base 2 of x times x minus 2. We're using the product property to condense because there's a plus sign here. If there's a minus sign, then we would use the quotient property. So that's our first step, condense. I'm going to say on both sides. Obviously here, you only need to condense on one side. Okay, then from here, there are two things that you can do. The first thing that you can do is you can put an exponential form from here. So remember, the base of the log is equal to the base of the exponential. So we have 2. Purpose of a log is to solve for an exponent. So our exponent is 3. And this is equal to x times x minus 2. And from here, let's just simplify this. So 2 to the third is 8. And x times x minus 2 is x squared minus 2x. Okay, now something to notice here. You can use this method I'll put it in blue. So this can be done because there is no log. On the right. So you can't just set it equal to each other. So the most common mistake that a student will make is they'll say x squared minus 2x equals 3. This is not an argument. So you are not using this as your step 2, okay? Because this is not an argument. Okay, now before we go through and solve this, I'm going to tell you what the second method is, okay? So we're going to go back to this step right here. So I'll rewrite it. We had log base 2 of x times x minus 2 is equal to 3. And the second method is to multiply the right side by log base 2 of 2. And the reason why we can do this is that log base 2 of 2 is equal to 1, okay? The reason why we're using log base 2 as our base is that the log on the left is base 2. If the log on the left was base 3, then you would be multiplying by log base 3 of 3, okay? And the reason why you do it is because that is always equal to 1. Log base A of A is 1. So when you multiply something by 1, you're not changing it in any way. So what do we get? We get log base 2 of x times x minus 2 is equal to 3 times log base 2 of 2. And what do we do here? We get rid of the coefficients. And then we can use that rule that if the bases are equal, the arguments are equal. So it kind of depends on what you're most comfortable with. This is more steps, okay? Because this will give us log base 2 of x times x minus 2 is equal to log base 2 of 2 to the third. Now we can say x times x minus 2 is equal to 2 to the third. That's where we say the arguments are equal to each other. And now we're going back to where we left off with the other method. So you can see this is more like one step, whereas this is 2 or 3 steps depending on how you go about doing it, right? Now from here, you just solve for x. So this is a quadratic. So this is quadratic, meaning you want to set it equal to 0. And then you can use any one of the methods that we talked about for solving quadratic equation. So you can either factor, you can use a quadratic formula, you can complete the square. I recommend that if it's factorable, you factor. This is factorable, okay? You get, and I'll put this here, you do not need to write this, you can just factor. But just for your benefit, negative 4 times 2 is negative 8. And negative 4 plus 2 is -2. This is your two numbers that multiply to C and add to B. So that means that our factors are x minus 4 and x plus 2. So either x equals 4 or x equals -2. Okay, right? From here we got either x minus 4 equals 0 or x plus 2 equals 0. So that's where we got this x equals 4 and x equals 2 from. And then we have to make sure that it's not extraneous. Okay, so we have to plug it into the original arguments. So we're plugging in here. So -2 we already know is extraneous because -2 is less than 0. But be careful here. Not in most cases, in a lot of cases, you could plug in a negative number and still get a positive argument. So don't just assume that because x is negative, it's an extraneous solution. It's extraneous because the argument is negative, not because the number is negative. Okay, and it would be enough for me here if you just boxed your answer and you said, you have to write this, x equals -2 is extraneous. And I'm going to put in as extra, you don't have to write this when you do your final answers, but this is because the argument is negative. Not because x is negative. Your x could be positive and you'll get an extraneous solution and it'll be extraneous, okay? And your x could be negative and it might not be extraneous. So don't just make an assumption. Okay, let's take another one. You should be starting to get the hang of these, so I would consider stopping the video after this one and seeing if you can do it. So this is log of x minus 2 plus log of x minus 3 is equal to log of x squared minus x. Okay, it's not really going to get uglier than this. This is as bad as it's going to get. Notice it's all the same base, so we can continue. If you see a different base, you have to stop, and you won't. So we're going to condense first. Condensing means multiplying. X minus 2 times x minus 3. So we can set the arguments equal to each other. Now, you can choose to multiply x minus 2, x minus 3 first, and then set the arguments equal to each other, or set the arguments equal to each other and then multiply. It's up to you. I'm just going to set the arguments equal and then multiply. So we have x minus 2 times x minus 3 is equal to x squared minus x. Notice we didn't have to choose between two methods here because we had a log on both sides. In the previous equation, there was no log on the right, which is why we could use either method, but we couldn't just set things equal. We had to do something first. So x minus 2 times x minus 3 is x squared minus 5x plus 6. This is quadratic, so we set it equal to 0. That means we're subtracting x squared and adding x. And you'll see x squared actually winds up canceling. So something that looks like it might be kind of annoying because it's quadratic. Quadratic is always more annoying than linear. this actually turns out to be linear, so it's fine. We get negative 4x plus 6 equals 0. And if you had wanted to, if you recognize that the x squared would go away, then theoretically you didn't have to add the x to both sides, okay? Now we have to add 4x to both sides because we need the x's on the opposite side of the constants. It doesn't really save you a step because either way, I'll redo this in blue. Either way, you would have to, even if you knew that you could, even if you knew that the x squares would have canceled, you still would have had to add 5x to both sides. So you're not really saving yourself anything. So the 4x's cancel, and what we're left with is 6 is equal to 4x. Divide both sides by 4. Okay, when you divide both sides by 4, reduce your fraction. You get 3 halves. And then you need to check and you need to make sure it's not extraneous. So you have to plug it into every one of these. You can't just plug it into one. Okay, so 3 halves minus 2. Actually is less than 0. Okay, 3 halves is 1.5. 1.5 minus 2 is negative. So once you get a negative, you actually don't have to plug it into every argument. So the fact that we plugged it in here first saved us some time because we're done. We know that this is extraneous. And I wouldn't just put an x through it just because I wouldn't take off points if you put an x through it, but you just want me to be able to see what the answer was. You cannot just say there is no answer. Okay, you're saying that here's the answer to this quadratic equation here. It's just that when we make it logarithmic, it is not a solution. Okay, so let's just do a quick review what we did. We condensed. We set the arguments equal to each other because the bases were equal. Then we solved the quadratic, which actually turned out to be linear. And we checked for extraneous solutions. Okay, another one. And again, these are all very, very, very similar. So from here on out, it's just repeating different types of equations. You know, we've essentially done the different types of equations. So now it's mixing and matching. Some of them you're going to use different methods for, but we've covered everything. So at this point, you should definitely be stopping the video to try them on your own, okay? So number 6, we have log of 4x minus 15 is equal to the log of 6x plus 9. So the thing here is that we have one log on each side, so we don't need to condense. Condensing isn't necessary when there's already one log on each side. And our steps are always going to be the same. You're going to know that condensing isn't necessary because how can you condense this? Condensing means to make it 1 log. So we already have 1 log. So now this is just a linear equation. We set the arguments equal to each other because the bases are equal. 4x minus 15 equals 6x plus 9. If we solve this, we're going to subtract 4x from both sides and subtract 9 from both sides. So we get negative 24 is equal to 2x. We can divide both sides by 2. And we get that x equals negative 12. Again, do not just assume that this is extraneous because we get a negative answer. You have to plug it in. So we're going to plug it in. Let's plug it in on the left first. 4 times negative 12 minus 15. And this is, in fact, less than 0. We don't have to bother with the other side. This is extraneous. Okay, so you're not boxing it. You don't want to box it. It's not a solution to the original equation. It's just a solution to this linear equation. Okay, let's take another example. So we have ln of x minus 4 plus ln of x plus 2 is equal to ln of x plus 10. So this is a case where we want to condense first. And that's because we have 2 logs on the left. So you cannot solve these equations when you have more than 1 log on a side. You just can't do it. So here when we condense, this is addition, so we're going to use the product property. So we get ln of x minus 4 times x plus 2 is equal to ln of x plus 10. And again, you can multiply this x minus 4, x plus 2 now, or you can multiply it after we set the arguments equal to each other. I'm going to do it after. There's not really a reason either way. It's the same number of steps, so whichever you prefer. So x minus 4 times x plus 2 is x squared minus 2x minus 8 is equal to x plus 10. This is quadratic because we have a square. So we're going to subtract x and subtract 10 from both sides. That gives us x squared minus 3x minus 18 is equal to 0. And this is factorable. Again, you can use completing the square. You can use the quadratic formula. If it depends on how good you are with your numbers. So if you're good with your numbers, then it's easy to factor. If you're not, then quadratic formula might be much easier for you. Doesn't matter. So we have negative 6 plus 3 will give us negative 3, and negative 6 times 3 gives us the negative 18. So that means that our factors are x minus 6 and x plus 3. X minus 6 equals 0. X plus 3 equals 0. So our two answers are x equals 6 and x equals negative 3. So we need to check that they're whether or not they're extraneous. So 6 minus 4 is greater than 0. We're okay. So that means that we have to keep checking. 6 plus 2 is greater than 0. And 6 plus 10 is greater than 0. So 6 is a solution. Negative 3 minus 4 is less than 0. Negative 3 is extraneous. And we're done there. Okay, let's take another one. Just to make things interesting, let's say that we have ln of x plus 4, and instead of plus, let's make it minus. So ln of x plus 4 minus ln of x minus 2 is equal to ln of x. And notice here we have 2 logs on one side, so we have to condense. And here we're going to use the quotient property. This is the one that says if you're subtracting, then you can combine it, you can condense it to one log, and it would be division. So that means that we're going to have ln of x plus 4 over x minus 2 is equal to ln of x. And now we keep going. Nothing really changes. We're still setting both sides equal to each other. Setting the arguments equal to each other. So x plus 4 over x minus 2 is equal to x. You cannot cancel the x's here. You cannot cancel the x's, okay? There are invisible parentheses around the numerator and around the denominator. You can't just cancel the x's. That would go against order of operations. The x has to be added to the 4 before it gets divided by any sort of x. So what do we do here? Well, we want to get rid of this denominator. So we're going to multiply both sides by x minus 2. And what that does is it gets rid of the denominator here. Sorry, I did not mean to cross that out. Okay, so what we wind up with, going to the next page, is x plus 4 is equal to x times x minus 2, or x plus 4 is equal to x squared minus 2x. Okay, so now this is quadratic. We have an x squared, so we're going to move everything over to one side and set it equal to 0. Notice that with any quadratic, you have to set it equal to 0 in order to use any of the 3 methods to solve. So we subtract x and subtract 4 from both sides. I'm just used to working with my quadratics where everything is on the left and the 0 is on the right. So we're going to write this as x squared minus 3x minus 4 is equal to 0. This is factorable. Negative 4 times 1 gives us negative 4, and negative 4 plus 1 gives us negative 3. Again, you can use the quadratic formula. We get x minus 4 times x plus 1 equals 0. So x minus 4 equals 0. X plus 1 equals 0. And our two answers are x equals 4 and x equals -1. So we're going to check for extraneous. We go back to the original here. So we're looking at the original arguments. You can see 4 plus 4 works. It's greater than 0. 4 minus 2 is greater than 0. 4 is greater than 0. -2, you can see just from this argument right here that it won't work. Okay. So 4 plus 4 greater than 0. 4 minus 2 greater than 0. 4 is greater than 0. And here, doesn't matter which one you plug it into, -1 minus 2 is less than 0. So this is extraneous, and x equals 4 is not. X equals 4 is our solution. And if both have been extraneous, that would have been perfectly fine. It just means that there are no solutions to that particular logarithmic equation. Okay, we're going to do 2 more. So to make it interesting again, we're going to do subtraction. So log base 4 of x minus log base 4 of x minus 1 is equal to 1/2. So we have more than one log, so we have to condense. And once again, we're going to condense using the quotient property. So we get log base 4 of x over x minus 1 is equal to 1/2. Okay, so now we can get rid of this log in one of 2 ways. We can either multiply both sides by log base 4 of 4, and then take this 1/2 and move it into an exponent like we did here. We multiply both sides by log base 2 of 2, and then we made the 3 an exponent. So here we could do the same thing, but we would be multiplying by log base 4 of 4 because we have a base 4 on this side. Okay, so we can do that, or you can put it in exponential form. Remember, we can multiply by log base 4 of 4 because log base 4 of 4 is 1. I'm going to put this in exponential form. So if we put it in exponential form, the base of the logarithmic is the same as the base of the exponential. So we have 4. Purpose of a log is to solve for the exponents. So this is our exponent. So 4 to the 1/2 is equal to our argument, x over x minus 1. And 4 to the 1/2 is the same thing as the square root of 4. And when we start doing radicals, you'll see this. 4 to the 1/2 is the square root of 4, which is just 2. So we get 2 is equal to x over x minus 1. We can multiply both sides by x minus 1. That's going to give us 2x minus 1 equals x. Subtract x from both sides. Sorry, 2x minus 2. So we can subtract 2x from both sides. That gives us negative 2 equals negative x. Divide both sides by negative 1. And our final answer is x equals 2. And we can check for extraneous. We go to the original. The original argument, 2 is greater than 0, and 2 minus 1 is greater than 0. So x equals 2 is a solution. Okay, let's do one last one. So last one, log base 2 of x plus log base 2 of x plus 2 is equal to log base 2 of x plus 6. Okay. We have more than one log on one of the sides. So we know first thing that we have to do is condense. So log base 2 of x times x plus 2 is equal to log base 2 of x plus 6. The bases are the same, so the arguments are the same. X times x plus 2 equals x plus 6. Distribute. X squared plus 2x equals x plus 6. Okay, so we condensed, set the arguments equal to each other. Now we have a quadratic. Subtract x and subtract 6 from both sides. That's going to give us x squared plus x minus 6 equals 0. And I'm going to move this up here. We know negative 3 plus 2 equals negative 1, and negative 3 times 2 is equal to negative 6. So x minus 3 times x plus 2 is equal to 0. X minus 3 equals 0. This is the 0 property. X plus 2 equals 0. So x equals 3 or x equals negative 2. Now we're just checking for extraneous. So negative 2 is less than 0. Negative 2 is extraneous, right? Because we're plugging it into the first argument here. Now we have to do the same thing with 3. 3 is greater than 0, so we have to go to the second argument. 3 plus 2 is greater than 0, yes. And 3 plus 6 is greater than 0. So all three of these tell us this is a solution. Well, x equals negative 2 is extraneous. Okay, so first thing to do is to condense. Then we're either setting the arguments equal to each other, or we have to put an exponential form or get logs on both sides. Okay, and then we're going to wind up with a quadratic or a linear. We solve that for x and we check for extraneous solutions. And that's it.